How's it going, everybody?
Right.
I'm Philip Ong,
I'm
here with
Dane.
Dane DuPont. I'll give you guys a volcano update, our weekly update here, following up on our one we did last week when we had a pretty exciting event on Kilauea. Yeah, Dane?
Yeah, it was an interesting one. Change of pace for the past 2 years. From the more stable background levels of activity that we're kind of getting used to in the past, short little while.
Right. So yeah, should we get into
So
it?
we'll get into it. Start with Kilauea first this time. A little change up from last time, since that's where we were talking about. We had a little bit more continuation from USGS. If anybody was watching last time, they'll remember that as we were talking about this event that took place the day prior, 2 days prior to our live stream, USGS put out a statement about it. So we read the statement online, and now they put out a continuation, kind of teasing what they're going to be putting out in the next week with a little bit, more refined, more detailed analysis of what actually, what they think happened up there. And we're going to kind of go through that signal again and what we think it was and where we might be going from here.
Yeah, for sure. Yeah, so thanks for the intro. And so we can look at our plots here. We're on a USGS information page. We're looking at the signal that was kind of the biggest tip-off that something was happening up there. And because this has happened over 7 days ago now, we don't have that signal on our 2-day plot here at the top or in our week plot here in the middle, right? So we can kind of, if we want to see it, we got to zoom in here to this month plot right over there. And this is where the signal actually is showing us right in there. That kind of big jump we had going from farther up, or down or up like that, right? So what you can see is that kind of this S-shaped curve is stabilized after the fact, right? It didn't kind of keep going up forever. It was almost like it kind of lurched and then caught itself, and whatever pressure was built up was relieved, right?
Right. And the interesting thing about that jump, just in and of itself, if we were just looking at that one tilt meter, then there's other explanations that may come into play as to how do you get a jump on a tilt meter. And one of the things we were talking about initially was maybe somebody kicked it, or nene, or some little dumb thing that messes with it. But the thing that told us that it was a real signal was the earthquakes. What was it? 200 earthquakes in under a day, I think it was.
Yeah, I think so. Yeah, we can look at the actual USGS statement in a bit if we like. Yeah, but we can maybe start off by just reviewing what they said about the actual tilt event here. If I may, Dane, they said between November 30th and December 2nd, several hundred earthquakes occurred between 1 and 3 miles beneath Kilauea Summit Upper East Rift Zone. On December 2nd, a transient increase in ground information resulted in about 3 inches of uplift of the caldera floor. This was about 4 months of uplift in just 4 hours. Monitoring data suggest that from the summit region indicated that a small injection of magma intruded below the surface of the volcano. Although magma didn't make it to the surface, this event demonstrated that magma continues to refill the storage system within a volcano. Next week, Volcano Watch will provide more information on this activity. So we'll all sit on the edge of our seats until next week for that further information, but they kind of revealed a lot there by saying that there was actually an injection of magma that didn't make it to the surface, but still it was a movement of magma that was under pressure and was able to move into some space somewhere in a localized to the summit region.
Right.
How does that make you feel, Dan?
And one of the
How does that make you feel? That we have magma injecting in the summit?
Like it's a Friday,
Yeah.
We're talking about Hualalai and magma injecting under Hualalai Summit, then oh my God! But a small. One of the keywords here is small injection, and we do think it was a small injection. If larger injections would have more quakes, more deformation, more signal, and maybe even after effect. But right now it's just. We had a signal. The signal stopped after a few days, and now we're kind of more along previous trends. But the thing about the previous trend is it was a trend towards pressurization of the summit. It was a slow trend, We don't know exactly where we are on that path to pressurization and, potential eruption, but we know that we're on that path, that the pressurization is a process that is occurring at the summit and has been occurring for months to years. Since the end of the 2018 eruption, it was, settling, recharging, repressurizing. And we're getting into that, that later stage. So it is a unique event in that we've had 2 years of quiet, right? If you go back a few years and you talk about like there was a small intrusion of magma under the Kilauea summit. It's like, okay, yeah. But now it's more interesting because we have that water lake up there, right? And that we're just getting to the point where that lake's starting to seem like it's entered into an equilibrium. And now we're talking about, okay, so there might be activity up there that potentially in the future will compromise that lake. And we don't know the timeline for that, but one thing we know for certain is that that new lake in Kilauea has a time limit associated with it until it evaporates and is gone. And that area, that pit, that collapsed pit, is refilled with magma. It's happened, countless times up there over the centuries.
Mm-hmm. That's right. Yeah, it's just a matter of time. It's not a matter of if, but a matter of when, as we have said for a long time, on this volcano, right? And yeah, it's a good point that, this was 3-4 years ago and there was this little injection of magma somewhere near the summit, it would just be like, okay, it's just another day, another ordinary day, right? That's normal, right? Yeah. So in that sense, it's kind of a return to an old normal, a little bit, right? That's kind of, that is a novelty of it itself, right? Is that it hasn't been normal for a while. Right, we kind of still hung over from the collapse. Yeah.
So
yeah, since we had the tilt signal up here on the screen and talking about what's stirring down there, one thing that we continue to see are these deflation inflation cycles. Yeah, you kind of see that there are these on the week-long plot here at the top. It's a little more obvious, right? This big long decrease, increase, decrease, kind of doing that sawtooth pattern like that, right? And it's present the last month as well, and it's been happening pretty commonly, right? Down, up, down, up, down, up, and up. We can trace it all the way, right? And so we have it happening over here before this event, and kind of right afterwards, it kind of just picks back up and keeps going. Right. So one thing that's been interesting, that we've talked about a little bit is like what connection do the deflation inflations have to what's happening inside of the magma chamber, and does that mean anything important about whether it's going to be erupting more or less? And this is an interesting one, huh? What do you think, Dane?
Right. That was one of the kind of the thought behind the. You want to go into the thoughts behind what is a DI cycle? Just brief overview so people kind of understand the action. Or what is thought to be the action?
Yeah, it's not really well known, but it's essentially a depressurization and repressurization, and it's thought to be connected to the movement of gas within gas or some other kind of, maybe it's really gas-rich magma like frothy, or it's just something with some different kind of fluid in there that's moving, and it's able to depressurize the chamber as that slug of material moves through the system, kind of thing, right? And so it sounds kind of mysterious, right? It's not something we can really see happening. It's something that we can listen for, and listen for the vibrations and the seismic signals, and see the changes that happen when changes in a volcano occur, and try to calculate that backwards and say, okay, well, it must be something like this is going on, but we really don't have that good an idea of what's happening in there.
Right, and the thing about the DI cycles is they come and go, right? There's periods where you might get only a single or no DI cycles in a month, and there might be periods like this one where it's just DI cycle after DI cycle, back to back to back to back, the entire month long. The interesting thing about this plot to me in the tilt is that we had this change last week, and if right when we did that live, it was starting to level off after that jump, right, that we were discussing. So, and then since then, it just went right back into a DI cycle like it was nothing. Like it just right back into it. And that's, interesting in and of itself. That would suggest to me that whatever was the change it was a small change. As you know, USGS put it, it's a small injection. If it was a large injection, I might expect that DI cycle not to happen or to be different or just the timing, but it just right back in line.
Right.
And
yeah, it doesn't appear to have changed the dynamics of that chamber at all.
Right.
Yeah?
Right. Whatever happened without significant impact on whatever that cycle is or whatever mechanism that's driving it.
Yeah. So it was maybe something more localized to where the tilt meter happened to be on that part of the caldera wall. Some adjustment like that, right? Adjustment external to the magma chamber. Like so wherever that little injection was, it was on a farther away part of it, and the chamber itself didn't really even notice. Right, at least if the DI signals are any indication. Yeah, so good point.
It's what's interesting to me, it's with Kilauea, you can have 3 inches of uplift in 4 hours, and that doesn't change, like the watch level or anything. Everybody's just like, yeah, it's bumping. Don't worry about it. Don't worry about that little guy over there. Don't worry about that one. On another volcano, Kīlauea Mauna Loa, you'd be like, oh, hold on here, let's look at this thing for a minute. But just Kilauea is such a beast that even that amount of uplift in short time doesn't mean all of that much. It was just worthy of putting out a little notification like, yeah, we see it. Which is interesting in the grand scheme of things. And we'll get into the volcano alert level in a minute.
Yeah, even still, I won't be surprised to see if it does go up, right? Speaking of that alert level, we'll go over more signals, right? But you could probably argue either way. It kind of depends on the philosophy and attitude, and the decision trees and all those things that USGS is working with. That
the one thing
complexities.
Doing, right. One thing you're kind of doing with it is setting precedent, since there has never been a raising from Kilauea green to yellow since the system was created.
Yeah, that's true.
So now we're just, we're getting into that point. So whatever you do now, it actually next time they, if it 2 decades from now, it's Kilauea erupts and then it goes back down to green, and we have some period. This will be what they look at in terms of figuring out when to next time raise it back to yellow from green. So it's kind of an important decision on where do you draw that line. Right, this is the first line is the most important on this one type of thing. Like you're setting the baseline on where you're going to start moving against. So it's it's a tough decision, and the guys at USGS have a lot of different variables to manage to be able to reach that, and then being able to communicate it too, right? Because just because you decide to raise it, now you have to be able to convey it to the public, not to blow their minds and think the thing's going to go Mount St. Helens on you all of a sudden, right? You get that communication is important. So it's a challenge, and it's pressure that it's easy to armchair quarterback and be like, oh yeah, raise the level up to yellow, but there's a lot of stuff riding on that alert level and what you're doing with it and why and how you're conveying it.
Yeah, for sure. And certainly the background level of activity is a consideration. We're sure of that. Yeah, so.
Right.
Check out the earthquakes here, Dane. This is our just past week of earthquakes chart that we have here for Kilauea, showing, this is the USGS automatic plot, right? Their automatic magnitude cutoff is a little bit different, but on this plot they're showing 661 events. And you can see they're mostly here underneath the summit. I'm going to zoom in even a little more here. All right, so you guys can maybe get a better look at what's going on here. So here's Kilauea summit right in here. You can see that over the last week, more earthquakes towards the beginning of the week than towards the end of the week, but there definitely was activity under the summit still. We still see this kind of trace going southwest right here, right? You can almost see this kind of northeast southwest line right in there. And we certainly see this big southeast extension right here. That's the Upper East Rift Zone. All right, so the earthquakes are still kind of active in those areas, right? This particular plot, the USGS is automatically creating is colored by depth and not by time, right? So these blue ones right here down in a lower left corner, this is the Pahala earthquakes that are down really deep in an order of 30 kilometers down. And interestingly, there was one of those, one big one, with a 3.3 that happened in Kilauea last week. There it is, and you can kind of see some smaller ones kind of scattered around here and there across, right? So then you had some ideas about this. You know, talk about this a little bit.
Yeah, so one of the things that we've always, we talked with Brian Shiro when he was working with USGS on Kilauea HVO about this area in particular and what those earthquakes can mean. And one of the things about it is the depth. The traditional understanding was that the depth suggested that there was a decollectment fault that was connecting the Pahala area to the Kilauea summit in some way, shape, or form. Right? There's a way to transit the magma in that area. So you get these earthquakes at that, super deep earthquakes. And the thing about those is they really cluster around Pahala. But if you're not going to look at Pahala and you want to find those quakes, you draw a line from Pahala towards the Kilauea summit. And the further they are from Pahala, the less likely they are to occur. But that's where they will occur, right? And just this one blue one that's up by the Kilauea summit, it looks like initially you're like, oh yeah, that's associated with all the other ones around the Kilauea summit. It's like not necessarily. There could be a deeper mechanism at play, especially considering how active Pahala has been over the past year. That is, continuing that. It's the real question is what is Pahala, right? And we've asked this question many times before. What do these earthquakes mean? Is it a connection just to Kilauea? Is it a connection to Kilauea and Mauna Loa? Does Loihi even play into this thing? Or does it not even connect to any of them? Right? And it's some other weird storage area or something, but that area has always been kind of a mystery. So when we see, like this one blue one up there, which was what was the magnitude on that one?
That was a 3.3.
4? 3.3? I don't know. I'm asking.
Yeah, 3.3.
Okay. Yeah, so you get these ones in there, and we've seen some 3s and 4s associated with Pahala as well, right? So that's in its realm of possibility to do. So it's just an interesting, it seems like a one-off type of thing on this map, but if you were to fill in all the Pahalas from the last decade or something, it would be within the range. I would argue that one-off blue one that he's by the summit.
Right. Yeah. We can compare some of the other plots that we have. Although a lot of the shallow earthquakes kind of drown this lower signal. You don't always see it so well, right? But we do believe that there is some vertical conduit somewhere, near the caldera that kind of comes up from some depth. And we have all these deep pathways over here. And we've also heard discussions, it's been basically a year. It's been almost since last year's Volcano Awareness Month that we were, getting information from some of the scientists that there might be several clouds within this Pahala zone, that some might feed Kilauea, some might feed Mauna Loa, but that was all really kind of enigmatic still at that point, right? And they're still, I'm sure, looking at that. One thing I wanted to do here, Dana, is scroll us down, because USGS actually does put like a cross section on here, right? This is like a plot of depth against the longitude here. And so you can see the blue ones. These are the Pahala earthquakes right down in here. Right, here's that big 3.3, and those other little ones that kind of were off to the side, right, of Kilauea there. And then up here is a summit magma area right in here, right? So
shallow.
This may well be some kind of pathway we're looking at right here that comes up and over. Although that's very, very mysterious, and that's just a sketch of it, obviously, right? But that might be one way you might connect it, and it might be way more complicated than that.
And that is kind of the traditional, understanding of that area too, is that there is a connection between them. There's just so many unknowns in that area, and it's kind of just based on the depths, the earthquakes and depths of where the decollectment fault is, assumed to be in that area or thought to be in that area, and it's just like, oh, they're the same, must be connected, but it's really hard to know in that area. But it does kind of look like it when you start playing with earthquakes like that.
Yeah. Here's our past year, right? So you can kind of see in the past year that there's a few more of those blue ones right in there. And I'll scroll down here to the cross section, right? And you can kind of see that over the last year, here's our Pahala grouping, right? There's clearly something happening all through here as well. And this last one we had kind of follows in that pattern. That's really interesting to see too.
Right.
Right. So that's,
and it's really an interesting area, that Pahala area, because you normally, when you're talking like volcanic eruption, you're looking for earthquakes, right? But you're looking for shallow ones, but you are looking for the earthquakes, and Pahala has been having a ton of them. But you can't even say, we have no idea on how long that even takes from, say, you have a bunch of activity at Pahala. Does it translate to something at the summit? If it does, how long does it take? All unknowns. All unknowns.
Exactly. Yeah, it's interesting. It's interesting that we can see so much. We have such a good monitoring network that we can, feel and see and get so much data. That's kind of one of the reasons why, Kilauea is such a hotbed of research, and we'll talk about that a little bit more later too. But so I wanted to look at rates and depths here. We have an intruder.
Yeah. Dog heard something.
So
sorry.
This is an interesting plot of our earthquake rates and depths for the past year here. I'm gonna make sure I get the right end of the plot here on a chart too, right? So okay, you can see that here at the tail end, we're at this level right in here, somewhere right in there. Yeah, you can see that last month we did have times with more earthquakes on Kilauea. That's kind of the summit flurry we were talking about right there. There were times in October where we had similar high elevated levels of earthquakes as well. But the overall background level, it seems fairly steady, right? And wasn't been that long. We actually had a little dip in November as well too, right in here. And as far as like where the earthquakes are happening in depth, you can kind of see that this bottom plot's a little bit different now. Now this plot in the bottom going this way is time, right? So over here is November, and back over here is May, right? So you can kind of see that the depth has been going off. The Pahala earthquakes have been kind of steady. And if anything, there are times when you get more of them, like seemingly right through here, and times when you might get less of them, like right through here. But they're fairly steady. Yeah, and the same thing for the summit, upper elevations right in here, shallower depths. So that's the kind of the summary for the seismicity on Kilauea. Yeah, so it's definitely within the range of what's been happening last year. There's nothing that abnormal. There hasn't been that many earthquakes really when it comes down to it, right? We haven't had thousands of earthquakes in a single day, like you might have with some of the events that I've been used to, some of the other failed eruptions, intrusions, dikes that have just filled cracks underground, right? So
right, and that's what it seems like this one was a crack existed, some void area under the summit, the magma filled it in, and that was kind of that. Right, it didn't get into a runaway eruption signal. It just filled in the void, created a few earthquakes, and then went back to doing what it was doing before. That's kind of where I'm looking at it from.
Yeah. So here's our GPS plot. Now that it's been a few days, we can actually see that there's some data coming in that's enough to maybe look at closely. Although there's not that much. There's maybe 8-9 data points if you have one per day since that event happened on December 2nd. And so, but you can kind of see here at the right end of this, the GPS plot right in here that we did have. Let me zoom into this more so it's a little easier to see because it's kind of small there for everybody, I am sure. But there, that's as big as I can easily make it. So you can see it actually went quite a bit, quite steeply, right? When that event was happening, adjusting afterwards. And since then it's basically stabilized, right? So we can kind of see that we're back on track, or we're kind of, recovering still from that signal as far as the summit distance across the caldera. Right. On the rift zone, we didn't see that signal at all, even when we add the last 10 days of signal. Right. So nothing different right in there, kind of all the same right in there. And so that kind of, begs the question, like how widespread is a signal? Yeah.
Right, it seems like mostly confined to the summit or nearby.
Right, that was our assessment last week, and we're just looking at the tilt meters, and we can look now at the 2-year GPS that similarly have a little bit more data. So this is Ue Kahuna right here. Right, that summit station, that's one of the ones that's used for that difference. So you can kind of see that clear signal right in there. And we can kind of see that there is a big increase at Byron's Ledge over here on the right. Just looking at the last 8 to 10 data points here on a plot, right? Likewise, I'm up in here. Right, but those are summit stations, and even one summit station, the Crater Rim station over here, does not really show that, right? So it wasn't even seen across the whole summit. It was kind of, at least this particular block on the summit seems to be separated from the other one that moved as a result of that injection last week.
Right.
Looking at the outlet vent, we do see something right in here. So that's more on a western, southwestern side of the summit there. We're going to look at the East Rift stations. We got to keep in mind that this was a signal we've been looking at for a couple weeks now that has shown some differences in the last few months. So we're really only concerned with the last few data points. And the last few ones over here, not a whole lot of difference in Mauna Ulu. Maybe a little bump in there, but, kind of back to normal. Nothing really major happening there. Kind of Yohamo, same thing. We've had these smoke variations, but happening longer than the event at the summit. Kamomoa,
Right. Whatever
same
changes
story.
that you see there, that trend change is definitely before weeks before the event at the summit, the recent one last week on December 2nd.
You're right.
These
follow
are
this line down here. You guys probably can't read this, but this right here says October. October is when at this particular station at Kanano Yohamo when that turnaround happened, right? So this is what we're saying a few weeks ago. There were signs of building pressure, that there are signs of increased earthquakes in the Upper East Rift Zone on the summit. That the HVO had put out an alert as early as June, in fact, right? And so we're kind of seeing it spreading and building and building and building. And we're like, okay, well, something might happen at some point, and then it pops a little bit, and then it kind of recovers, and but changes are happening all around, right? But we're kind of have to focus in on that very particular small localized change that happened last week that was only in a summit area. Whereas there are bigger changes happening across the whole volcano, which is we're trying to help you guys understand, or maybe just like to know that someone's watching, and kind of that there are so many signals in the volcano, right? That someone can look at. So, all right, nothing really in a rift zone is that signal. Essentially, is what we're showing here. If we go to some of the stations that are kind of just south of the caldera, but essentially on the upper reaches of the south flank, like Ahua, we can see here, there actually might have been a little speed up in that south movement as a response to that summit event. And over here at Puhimau, something a little smaller, but maybe there's something going on there, slight speed up. So seems like it's localized. If anything, it was felt more to the south and the west than it was to the east.
right around the summit.
Right around the summit, yeah. So yeah, we've talked about how that whole piston has fallen in, and there could be cracks. Lava can go into anywhere along the edge of that caldera collapse, or the southwest rift is right over there. There could be a lot of possibilities. There's a south caldera chamber that's deeper. There's a shallow chamber that's not that far away, a little bit more to the north. A lot of dynamics in that small area that thing could have been anywhere in there, and we'll eagerly await the report next week for some more information about the details.
Right.
Anything else you want to add about what happened at the summit last week, Dane?
Let's just want to finish up on the alert level, USGS, the yellow or green, or want to talk about that a little bit more?
Yeah, sure.
Really,
yeah. I mean, go ahead.
Really, it's just where do you want to draw that line is with the question, right? And the thing right now is, the way I'm reading the USGS updates, and they're saying we'll wait until next week, so we'll provide more information on the activity. Doesn't seem like there's a rush on that, and since there isn't a rush on that, I don't think it's going to get raised immediately. Even though you might be able to, you would make an argument that it should be raised, and it would be a convincing argument to some type of thing. The way I'm reading the update that was put out yesterday, and their justification that they put out last week, whereas it returned to more normal activity. I don't think it's going to jump up in the next week, unless it happens again or something else happens, right? A new signal emerges, right? Then it would jump up. But as of right now, the way I'm looking at it, I don't think it's going to move up. What do you think? What are your thoughts on that?
I mean, I could go either way. I can really see how this fits into the pattern, right? There haven't been that many changes really, from the background. The biggest thing is we do have elevated earthquakes, and then we had that little excursion of the tilt, right? That's indicating an injection. But so the question is, what do you want your alert to actually capture? Is it like a threat to the people? Is it a threat of lava actually breaking the surface? I mean, what is it that you're really looking at, right? Because lava may actually have a decent chance of breaking the surface, but it's not going to be anywhere near any people where it's going to affect anybody. And at the rates if it's going to move at that slow pace, it's not going to explode anything, right? There's just not enough moving fast enough, right? So it's in that sense, does it really matter, right, to people, right? If you can't really get that close to it, and I mean, it's not likely to. We showed you guys the thermals last week of the pond. There was no change in the temperature. I mean, you couldn't see anything different, right? We can revisit that a little bit if we like in a bit, but there really hasn't been anything noticeable at the surface. If we didn't have a seismometer and a tilt meter, you wouldn't know really that there was anything changing, right?
So when I look at this, the only way I can see you screwing it up, right, in the alert level right now, is if you waited too long and you go from green, you go from green, skipping yellow straight to orange, right? If that happens, then that was a system failure, and that whatever that alert system was, whatever it's designed to do, is not meant to skip levels, right? There's going to be signals that lead up to it. It's just about the interpretation of them and being confident in being able to make that call, right? That's the only way to be wrong in this situation to me is if you wait too long, it goes from green and then something happens and you're like, oh, we're just going to orange right away. We're skipping yellow. That would be the only way to screw it up. If you can justify being at green, if you can justify being at yellow right now, okay, cool. Just that one instance of, we get into this ramp up and it might be a very short ramp up. We should be able to know that there is a potential for the ramp up and set the yellow accordingly to that potential, to me at least. You're getting real signals too, but you're looking for that it getting to the surface, that actual potential of eruption above background levels of activity for Kilauea resting over the past 2 years that we've seen, right? Just don't want to. That's the only one that I'm like, you might want to think about yellow just so you're ready, right? For yellow, it doesn't, and yellow doesn't mean that an eruption's imminent. I mean, we've sat at yellow for years on Mauna Loa and it hasn't done anything, right? So that's fine. You can do that, without hurting anybody. But yeah, if it just goes green to orange, then even if nothing happens and it only spatters in the park, it's gonna freak people out. Just because of the warning jump. So that's all it is, where I'm, that's the only thing I wanted to talk about on that alert system and the classification currently.
Yeah, no, it's a good point. I mean, it's what's the harm? That's the flip side of the coin. What's the harm in putting it to yellow, right? I mean, it's not going to change how anyone does anything except perhaps HVO, right? We do know that with the yellow alerts, we have weekly updates instead of monthly updates kind of thing. But
okay, let's go to yellow.
If it's changing quickly enough, then maybe it's worth it. If it's not, then maybe it's not. So I don't know. I mean, so yeah, we're not. It's not our call, obviously, and that's we won't be surprised if it happens, but also won't be surprised if it doesn't. If it takes it a while or it doesn't actually happen until something else changes. Some other signal, right? And on that, I kind of wanted to make sure that we do show for Kilauea, we do show the gas signal, right? So here's the last month of gas. The sensor is on HVO's page, and you kind of see the up and down spikes showing the high points. High points that maybe show when ideally the wind blows a gas towards the sensor. But there's no huge peak. There's nothing crazy there, right? This one over here on this lower plot's kind of hard to really see what's going on because this is the one we saw had gone offline, right? This kind of does show what it looks like might be a spike. That's showing it to be like on the 8th or something. That's not something we can really. I'm not sure we can. Having seen this instrument offline last week, I'm not convinced it's not just calibration, right?
Yeah,
we haven't seen it anywhere else.
The instrument. That happens, the SO2 meters, they're sensitive, they require upkeep and all that, maintenance, and sometimes they go off, sometimes they get miscalibrated, sometimes things happen and you have to adjust to it.
Yeah, For sure, yeah. So we can see that there's been no recent direct sampling of the lake, right? But they are still measuring a water depth at the lake there, and you can kind of see here at this right on the plot, it's kind of, not, you can't really tell any difference here at the last little bit here, what's happening. So maybe still be climbing very slowly, but it does seem like it's at a slower rate than before, right? So, and then kind of, let me, show you this. This is just that thermal of the last 24 hours of the lava lake there, right? So you can kind of see that we're still at that same temperatures we were at last week, that right around 90. There's a high of our range here. There's been no extra heat. There's been no effect after a week on that pond of water down there, right? So one thing I say also, we have seen some of these stations kind of go offline a little bit, right? Off and on, and we see the signals come back sometimes, right? One thing you got to keep in mind is that all this information is getting relayed by radio waves across the volcano, which means that there's an antenna somewhere where the station is that points to another antenna somewhere else in the volcano. Now, if that other one that's receiving it suddenly lurches and drops 4 inches in 4 hours or whatever it was, now suddenly your antenna may not be aligned anymore. And so you may have to go and realign all kinds of things, as the ground that your receivers are on are changing. And that's kind of one reason, another reason that the instruments can kind of come in and out of it, right? So there's a lot more data being collected than it actually makes it to the public interface where we can see it as the public, right? And so that's part of it as well. There's a whole different set of data that's more complete, that's behind the scenes, that I'm sure HVO had more time, they would actually be able to put more of it online. But as we know, they have their hands full with monitoring, right?
Right. So I have a question for you. What do you think USGS is doing right now? The calculations that they're doing on that intrusion? Can you just go through them roughly? Yeah.
So one thing that we know is that we have INSAR satellite flying over. The Sentinel satellites are flying over every 6 days. So they're not the only ones, but that's one of the more continual sources. And we know that there's INSAR data that's week by week, right? So we know that there is a period of time that catches this event on INSAR. And so INSAR is one way you can actually measure the movement of the ground kind of all over the place, not just where your GPS stations are. So that gives you a more complete picture and allows you to kind of make a model of the shape of the thing in 3D rather than just in 1 or 2D, right? If you have like a GPS station here or there, you only have a couple points where you can really make that inference. So I think the INSAR is a big part of it, and once you have all your INSAR data, you actually can go through and calculate based on what the satellite saw, what the difference in the ground was, and that difference in the ground over the range, the spread of it, how far wide, how broad it is. You can actually, do a mathematical model and say, okay, let's imagine it was something that was flat and long, or skinny and tall, or roundish, and does it actually approximate the signal we see in the surface? And you kind of can say, okay, well, of all those shapes, this is the one that fits the best. Okay, what size, how long, how tall, where exactly? So you can do all those things. You kind of hone it into like, okay, well, the best guess we have is that it was something at this shape, at this size, at this depth that caused the signal we saw at the surface. And you don't use just a satellite, but use a satellite and the GPS and the tilt and everything else you have. All of it goes into the big pot that kind of gets inverted into mathematical problem solving to actually find a solution of what the most likely cause was.
So then, hopefully next week they have something preliminarily along those lines to share. And
yeah.
For the public, the public version,
Well, we sure hope so. That's something that's going to be in the Volcano Watch next week. Yeah.
Right.
So that was a lot about Kilauea, and that's most of what we had to talk about today was Kilauea, right? And maybe a little bit more later, but we do want to make sure we do cover Mauna Loa as well today, right? And so when we look at the earthquake map here, I'm going to have to adjust my screen a little bit for this one. I have to force it to reload here. Mauna Loa monitoring map. And kind of zoom out here so you guys can see the earthquakes on Hawaii Island. Right, there is our cluster on Kilauea that we just talked about a little earlier, the summit, and Southeast Rift. Here's our Pahala Earthquakes. There's one that happened just recently within the last hour. And so Mauna Loa is overall fairly quiet, but we have had a couple clusters of earthquakes up here on this northwest flank, northwest of the summit, Mauna Loa. So let's zoom in a little more. show you guys what's going on here, right? If you can't see, the summit caldera of Mauna Loa, Mokuʻaweʻoweʻo, is right in here. It's not a very good outline, but that's where it is. And so there was kind of a couple clustering of earthquakes that have happened in the area right through here, right? And I believe the largest one was a week ago, and it was a 4.1, and that caused people who don't normally feel these earthquakes farther away, and maybe North Kona even, to actually feel this and report it. And we saw a lot of chatter online about that earthquake. Yeah. Right. Did you feel that one, Dane? Was that one of the ones that got you?
Yeah, I don't feel any of them. Unless it's over a 6, I don't feel it.
Yeah, so, Dane's got this thing, Earthquakes and Dane. If you haven't heard the story, right? Like,
the dog or something, the chair always.
So here are these earthquakes, Mauna Loa. And what I was going to do is maybe just show you guys how you can click on this earthquakes plot here on the USGS monitoring site. You can click select plot area. I'm just going to take the standard parameters there, and then I'm going to click 2 points on either side of this plot right there. It's going to make a box right there, and I can click view plot right there, and I'm going to zoom it in. You guys probably can't see any of that. But that right there is a plot of the depth of the earthquakes. Right here on the left axis is depth in miles. So this is 1.25 miles every line. Right, so 1.25, 2.5, 3 3/4, etc. But you have to recognize that sea level is the second one down because Mauna Loa is above sea level by that much. So these earthquakes above. So you can kind of see that they're all kind of shallow, right? All less than 3.5 miles or so. And they've been going on for over a week now, right? And so that 4 was probably this cluster right in here. Let's see if I can get it to highlight. Nope. 3.2, there's been a 3. Back over here, 3.3. So a lot of 3s, right? I was kind of noting to you earlier, Dan, that there's a lot of, across the whole island, if you look at the whole last month, there's been a lot of magnitude 3s, and even that one magnitude 4. Like 16 or 17 of those earthquakes. So quite a few. The most recent one, 2.4 here, that happened earlier today. This morning, right? Some smaller ones as well. So that's the Mauna Loa. I guess here, let's see if I can show you guys where that 4.1 actually was.
Elevated rates of earthquakes
Dane.
From, we're still sitting at pre-2018 eruption levels of earthquakes or above those, like elevated earthquake activity, which is the justification for, the yellow classification up there, or majority of it associated with, also with the deformation that's going on at the summit, the continuous inflation that it seems to be there with only slight variations in it. And so, we're just, going back over it, but it does look like there's, especially off of this to the northwest in that little earthquake area, the third most common area for earthquakes on Mauna Loa. Like there's all around that summit, there's 3 little spots, and those spots are just the spots on Mauna Loa if you want an earthquake. And that's one of them right there where we're starting to see these earthquakes now. Right, that's one of the spots right there.
Yeah.
Other one's just
the past week right here.
Yep.
Yeah, so the past week, and then what Dana's saying, how it is a very persistent area over the past year. You can see that certainly there's that cloud in the northwest here that's kind of separate from this summit caldera area right over here. Right.
Right.
And what Dana was just saying, there's a plot for it right here, right? The plot for the past year on Mauna Loa, a little bit too big here. It's smaller.
Yeah, gonna have to go to 5 years to see the rate compared, but it's still at that, still holding steady.
Yeah, this is the most recent data point right here, right? It's a little bit higher than before because it has been quiet for a while right through here, right? But you can kind of see that it's really not to the levels of what we had earlier in August. Right, or even earlier, January, March, May, right? You can kind of see this is a fairly common level for the earthquakes to get to right in there.
Yeah.
Okay, so let me go to the 5 years
come and go
request here.
Yeah, they'll come and go. Then you'll get these little flurries of earthquakes, like we're kind of seeing, where it just comes in a little bunch in one particular area, and that's kind of like what we've been seeing. But right there, you can see the past 5 years of earthquake activity, and you can see that the 2018 eruption is the low point, and then you see the draw a little line there. Yeah. Left of that is a lower rate than the right of that, basically. Yep. And so, yeah, that's
we're still
on lower right now. Is earthquakes are still continuing, inflation still continuing. Some weird that anomaly on the GPS though is the interesting part.
Yeah. So we can get to that in a second. I just want to just make sure we also mention what HVO has said about this cluster earthquakes over here, right? That fell in that cloud, and that was put out in their Volcano Watch this week, right? As well as their Mauna Loa update this week. Is that there was a similar size earthquake in this area in November 2011, and there was no eruption. There was no other change in any of the signals. It was kind of the same as what's happening now. So that didn't change anything in the outlook for Mauna Loa. Long term, it's still kind of filling up, and you can kind of see there's a lot of earthquakes over the last year. It's definitely filling up. There's lava going in, magma coming in there. It's going to come out as lava someday, but not yet. There were similar clusters in that area. Like we're having following up to that, right? You might say it's maybe not just the aftershocks, but you can actually have, clusters that kind of flurry here and there. We've called them flurries before too. And those have happened in October 2018, right? Remember that one? It was just after the eruption, that kind of spike that happened. April 2017, July 2016, August 2015, and even earlier than that, right? So it's been happening for a while.
Right.
Yeah, so
that's why flare up from time to time.
Yeah. And so, but yes, the GPS, of course. I'll pull up the GPS here for you to describe, Dane.
So really this GPS, and you can take it off to the left and it will continue to do the same type of trend that you see there up until about October, where you get that shift that where it stops expanding between the caldera rim, right? The distance between them. That's what the main GPS at Mauna Loa that you'll probably see is showing is a distance between 2 points on the on each side of the caldera, right? So they expanded, they got bigger up until this October-ish trend change, where they stopped, right? And it dropped a little bit, or they closed up a little bit, it looks like, in the GPS, and then it just been steady since. So that was one of these little interesting things on Mauna Loa that's outside of the norm, where we've been seeing a lot of the consistent earthquake, consistent inflation for the past year and a half, it feels like, with only variations, flurries, and things like that thrown in. But this is one of those ones where, hey, that's a change, and we'll see if it gets, we've seen some changes before, some bumps, right? They do happen in the GPS, and we'll see if this gets back on the previous trend, or if this was, something else. Betting on Mauna Loa, I'd go with it gets back on the previous trend, because that's what it seems to be good at right now, is bumping and then getting back on what it was doing.
Yeah, certainly if you look at the last 5-year plot here, it's definitely a net up no matter which way you cut it, right?
Right.
But interestingly, there's also not been a drop as big as what we saw in the last month, in the last 5 years as well, right? There have been some other little aberrations, like right in here, or right in here, you can kind of see an up and a down, a little wiggle up and down, right? But like nothing quite, even in here it drops down and up and down and up, right?
Right.
So it does go through these periods of periodic adjustment there, right? That you kind of see.
But this is a big one, a bigger one than we've seen recently in terms of adjustments on looking at the GPS.
Yeah, exactly. So back to the past year here, you kind of get a little bit more resolution on what's happening here, right? This began in late October. That kind of corresponds to that same time as we had that Kīlauea earthquake and a flurry in late October that was just northwest of Volcano. And that's the area where Kilauea Mauna Loa push on each other, and it kind of slide back and forth over each other depending on which one is going to move which way at what moment in time, right? It can go either way.
True.
And so we know that after the summit collapse in 2018, basically Kilauea was more sagged, and now we know it's been inflated to the point where it can cause a little injection. And so certainly it's been bulging out and pushing against all those sliding zones more than it has before, right? More than it has before since 2018 eruption collapse. So,
Right.
you know, that could have been an adjustment of Kilauea, you know, but it also adjusted Mauna Loa since that's where they're kind of touching, right? And if they're, you know, if Kilauea is able to push, and Mauna Loa can't give it any space, then Mauna Loa is going to feel that push, and that push is going to get all the way into Mauna Loa. Whereas if Mauna Loa can suddenly let Kilauea slide by a little bit, now it doesn't feel it all that force quite as much. Maybe it can relax a little bit, just temporarily, because long term the magma is still coming in the volcano. You just don't see that change of it, right? And that relaxation is actually pretty localized in Mauna Loa as well. Something we can point out as well to you guys is that,
Right.
you know, that this line right here we're showing you guys is a summit line, right? It kind of goes from the station north of the summit to south of the summit, and how far they spread across, right? So this is like, you know, the difference between them, which is, you know, an important, more accurate measure. But we also have GPS stations on Mauna Loa, and let's see if I can get it to load here. 2-year GPS on Mauna Loa. So this one here is on the southeast flank at Ainepo Trail. And you can see that it also has had an adjustment since late October,
Yep.
right?
See it right there.
That station's at 12,570 feet. There's one on the west flank at 12,140 at Pohaku Kanalei. You can see that it also sees that signal. But those are really the only ones. You go down a mountain farther, 10,000 feet to the sleeping cave, no signal there. You go down to Kahuku, no signal there. All the way down to Ocean View, no signal there, right? So it's really localized to that upper part, right? Kind of above 12,000 feet elevation is where we're seeing that signal. So, and you know, it's not like it dropped and stayed down. It kind of dropped and now it's flattened out. It's kind of stabilized. It hasn't kept dropping. So that leads you to believe it's a temporary adjustment as well.
So, the one thing to restate is that we still expect the Mauna Loa to erupt next at the summit, just like Kilauea. And one follow-up on just Kilauea that we didn't get to talk about, but probably should, is that if there is an eruption, say in the next month or two, right, the expectation we have currently is that it will be small, right? It might throw, sputter for a little while, then go out. It might fill in the bottom of that collapse pit at Kilauea, but we don't expect a big eruption. And this goes back to, previous times, like after 1924, of prolonged periods of small activity. There's still activity, still eruption, but they're smaller, they're not high volume, they don't last a long time, right? It comes, sputters around a little bit, then goes back to resting, right? It's a spurring back to life type of thing. That's kind of what we're thinking about on Kilauea, at least. Mauna Loa, different story, but again, we're still expecting at the summit, summit first, then rift zones. Right, and that's kind of where both of them are at right now, is summit first. You're looking at the summit. Then we can talk about rift zones after that summit activity type of thing.
Yeah, for sure.
For sure.
So that kind of covers our normal bases for the volcanoes, right? Maybe Dane can kind of look over some of the questions and read them. I have a hard time kind of looking at them over here while I'm moving the screen around, but there are some questions that we do want to answer, and we're going to talk a little bit more about some of the science coming up, kind of to finish off here in a second. But first, some questions. So the question I can see is a question from Catherine, but where these graphs can be found, right? And so let me show you guys how to find these graphs, because it's not always the easiest to find them. So let me get my screen right here, you guys, and share my screen. All right, maybe. Come on, there we go. Okay, so this is the HVO from the HVO website. So let me come in. I can go back here at the top. I can type in HVO and show you guys how we get there from the main HVO homepage. Okay, main HVO homepage is loading. Looks a little funky here on the right, but you see over here under this box of yellow advisory of Mauna Loa, there is a monitoring button, link right in there. Monitoring link. So I'm going to click on that. And that's what brings me to this monitoring map right here. So
I'll put in the comments link for the
awesome.
the information data for Kilauea.
So this is the kind of the monitoring map, and what you have to kind of do is go in here to the layers and make sure you have all the different instruments turned on, right? And so when you have all these instruments turned on, all these different symbols appear here on a plot. And so here, let me try to get it to respond to me here, and zoom in. Seems like it's kind of frozen on me here. Okay. So I believe the yellow, the actual blue stars are GPS stations. So for example, there's one. There's another one right there. And so you can click on the instrument information right there, and then it should bring up a plot. And some of these are actually offline, so this is kind of a good example to show you guys that a lot of these are not online.
Should is a good word on that map. This should bring up an SO2 monitoring station, but it's dead. It broke years ago. You know.
Yeah. So I mean, so what I've done to kind of make this presentation for you guys is kind of pull out the ones that I know work and kind of compile them in one place so I can show you guys more easily, right? But so for example, right up here, here's one MLSP right by the summit. I can click on it, and it brings up this window that has GPS over 2 years, GPS over 10 years, summit information. So you can click on those plots that'll bring up these images that I'm showing you guys, right? Kind of just one at a time, but that's how you get to that. All right. So thanks for the question, Catherine. I think there was maybe one I spied earlier about the water. The water is still in the summit of Kilauea, and there's been no change there on that. So I'll make sure we just address that directly. Anything else to see on there, Dane? That's questions about what's happening in the volcanoes today.
Just Bob Dexter saying that it's 2020. There's nothing to worry about. This is maybe the truest statement. You know.
So we the 2020 roll call. Kilauea had to go put her hat in.
We'll see.
Okay.
Still got time. Still got 19 days, 20 days to crank one out.
Right.
To get it in.
Right. So we've been going close to an hour here, guys, and just kind of one last kind of thing to finish off with for you guys, and that's just a little bit of the science, right? Kind of want to let you guys know what's been going on, in our not just local island community, but our island science community as well, right? And one thing that's happening now is there's a virtual conference happening. The American Geophysical Union Conference happens every year. This year is virtual, but as always, USGS scientists are involved in a lot of the data presentations and a lot of the research and all of that. So we will have a few stories coming to you guys over the next, few weeks, couple months, that kind of focus on some of this more, all the different aspects of the research, right? And it kind of ranges all over, right? It kind of ranges from today we're going to talk about gravity, the gravity signals that were measured on Kilauea. But I also do studies on geochemistry, looking at the olivines and the temperatures and pressures they had to have come from to kind of see which way the magma is moved around during eruption, which is fascinating. There are studies that not to get too far into the weeds. There's lots of different kinds of studies that all different kinds of ways to look at the volcano eruption, which we'll cover. But today we'll focus just on the gravity. And the thing about the gravity is that it's a fairly new technique to measure gravity continuously. That means all the time, not just once a year coming by and seeing what changed, right, on the volcano. And so the once every year thing is something that's been happening for a while. We normally have gravity instruments, but they're often very expensive, very, very expensive. We're talking about tens of thousands of dollars, like at entry level ones, so that has kind of made a barrier to these instruments being deployed all over the place, for obvious reasons. So, but they're getting cheaper. There's new designs and all that, and they're being tested out in new places. And one thing that they actually were able to do is to put one instrument on Kilauea caldera floor, and one instrument in pool cone, kind of near the edge of the crater. And both of those instruments they had in the ground that were measuring gravity at the time of the eruption, collapse and eruption, they both measured record signals like that. I mean, the largest I've ever detected for gravity on the volcano, on any volcano anywhere, in fact. But partly it's because we haven't been measuring them, right? But partly because it also was a big movement of magma, right? One thing that's maybe a little nerdy, but the closer the magma is to the surface is how strong you can see the gravity signal. So that's something that matters too. Like, you don't work all over the place. But if you're going to try it anywhere, then on a rift zone where magma is moving underground, not that far underground, that's one of the best places to do it. And that's why the signal was so strong and, in fact, record-setting, right? And so they often measure this in, units they call milligals, right? They're kind of, small gravity units,
And that, gal stands for Galileo, and it's, I was going to make a bad joke about it, but I'm not going to. Something about how much weight, how much force he could muster if there was a lasso tied around the moon. That's what gal.
Save that for the physics class, yeah. But yeah, here's a picture of Kilauea Summit when it was draining away here, and so there's a article written up on this. It's on Hawaii Tracker. You can find a link on Facebook as well. But they're measuring, milligals, and the amount of measurement that they detected. The record-setting measurement is still only about a millionth of what you'd feel at the surface of the Earth, right? So it's a very tiny change, but the instruments can measure them. And there are kind of some nuances in there too, right? So
one of the things I remember just about the microgals is that even in the submarines that they use these as well to help guide the sub. And there's a whole bunch of very intricate tech going in there and knowledge, but that is something that a lot of subs will monitor, is the gravitational pull on them, and it's a really interesting metric to be thinking about for a submarine in water, right? But they do it. So
yeah,
a whole bunch of uses for this, but now we're starting to look into Kilauea as applied. Should be useful next time if we're had a monitoring system in place, and the science evolved a little bit, got a little more pushed forward to be able to have that kind of monitoring in place and start using it as a metric that you're monitoring, like every tilt GPS, INSAR, and all the fun stuff. It just it'd be good to be able to add that to it.
Yeah, for sure. Yeah, and not just because it's a different thing to do, but because it actually shows different stuff, right? The two plots here that were presented, right? The top plot's the summit. You can kind of see it starts off at a high value up here, and then it drops down, right? The Pu'o signal has this little wiggle first. We'll talk about it, and then it has this big going down, right? So the biggest signal is actually at Pu'o, not at the summit. More magma left at the summit for the signal to be detected, right? But actually, it was closer to the surface at Pu'o that it happened, right? So that's kind of why the signal is bigger there, I suspect. And there's a lot of kind of noise up in here. It's all up and down, right? This is when a Pu'o crater was collapsing at this point in time, right? The summit was starting to collapse also. Earthquakes are starting to happen. This is the beginning of that whole sequence of lots and lots and lots of earthquakes, right? So no surprise that this gets noisier and noisier right there. But one thing that was kind of pointed out is if you focus in on, oh, my screen just did something funny here. Let me get it back. If we focus in, if I can, it'll let me. There. Oh. All right, that's the magic of live streaming here. Let's see if I can get it to come back one more time. Hang on with you. There we go. Yeah, I'll leave it like that. We'll do it small. So right here, you see a signal that actually shows the signal dropping, then going up again before it stabilizes, right? So something happened right in there. And actually, what is believed to have happened is that there was an eruption, a very small eruption on Pu'o Cone itself, right? And this is something that, there's the instruments themselves that were used to measure this. The one on the right was one of the Pu'o, the one in the middle and the left is the Halemaumau one. But this is a picture taken on May 3rd of Pu'o Cone. And so we have a collapse happening over here in the main crater, right? But we also have this big line of gas right through here, right? And actually, this is the fissure. This was fissure 0 with fresh lava that came out and didn't go very far. But this was the first fissure of that whole sequence of the eruption of 2018. It was pressurization of some Hawaiʻi Mauna and Pu'o'o. Pu'o'o cracked, then it collapsed, and the magma went down towards Leilani, right? So the first signals are all the way up here at Pu'o'o. And of course, lava lake at Hawaiʻi Mauna was overflowing the days before that also because it got pressurized so much. So, but this feature right in here, this crack right in here, is the one that we believe is showing this signal, right? So what happens right here is gravity is just normal, nothing's changing. Now cracks open up. An area that had a rock in it now has space, and so the gravity is a little bit less. Now those cracks are getting filled with lava. The lava that comes into here is actually denser than all the spatter of the cone. So it refills it, makes the gravity higher, and then flattens out. So you've replaced spatter with air and an air with denser lava to form a little wiggle like that, right? And why does this matter? Because the collapse of Pu'o'o happens over here. This happened before the collapse, right? This was a day that was extremely rainy and cloudy. The tilt signal did not show this fissure this clearly. It was, that's something they really didn't know. That's why when we look at the first reports of when eruption actually happened, they're like, well, sometime between 2 o'clock and 4:30, something happened on Pu'o'o. And right, actually several things happened. It was a fissure happened, and then the collapse. It was a complicated signal. They couldn't separate it at the moment, in the day of, as they were issuing an alert for everyone to watch out, right? So that's why you want to put in gravity stations, on the rift zones, because you might get a signal that's easier to read than a tilt meter. Wouldn't that be great, right?
And so that's less volatile than a tilt meter would be awesome, so it doesn't get freaked out by the wind and the sunlight.
Yeah, I mean, gravity is a tricky thing, right? So I mean, these are that's why measuring gravity continuously is a tricky thing. Not to open a whole can of worms, but gravity varies all over the world. It varies by huge amounts. It's tricky to measure. Changes can happen for lots of reasons, but kind of consider that the scientists have addressed all of that, and here's what's left over. And then you do see the signals very clearly, and if they can come in real time, then that would be an awesome toolkit, right? Kind of another 21st century technique. Volcanology. You can have gravimeters combined with satellites in the air. Satellites are there was a gravity satellite mission at one point, but that's out of commission now. But so all kinds of different new technologies that we can't even imagine now that will be part of our toolkit going forward that can help us do better, right? Kind of help us with the response, which is really what we're after, right? But of course, for all the science nerds, it's an interesting curiosity as well.
Yep. Well, I think
there's more details. I can let you guys read more on the website. One of the interesting things is the density, right? They actually can calculate density of the magma by measuring gravity, because you can figure out how much mass had to have changed to cause a change in pole, right? And if you know the size of the crater the thing was in, which we have 3D models, you can calculate the density, right? The density at Hawaiʻi Mauna is different than at Pu'o'o, right? So that's interesting. So it's losing gas, right? It's losing gas on the way, and enough to change its density by 12%. So that's we talk about density changes. The densities of the magmas can change drastically, like when they're down deep in the South Caldera, hot and foamy, to when they come up and degas into the lava lake, and then they actually lose gas and get sucked back into the volcano. Now you have kind of flat magma mixing with the fresh magma inside of Hawaiʻi Mauna. Right, and it's got to have a different density and signal and all that stuff. It's a hugely complicated thing that we now have all these tools to try to untangle. So that's a fascinating thing scientifically about it.
Right. Well, very good. Yep, I think that gets us through. And one more update. We're gonna try and make this a weekly thing now. Right, come back each week, review the data streams, review what's new, what's different, try and touch on some interesting stuff in volcanology, maybe off the island too when something happens, but it's gonna, we're gonna try to do this more regularly. Try and make this a weekly thing right after USGS puts out their volcano updates. We're gonna go.
Yeah, so thank you guys for joining us. Yeah, hope you appreciate what we've shared, right? You guys can go and get all this original data from USGS, and of course listen to all the official products they put out. Their weekly updates in Mauna Loa, monthly updates on Kilauea, And next month will be Volcano Awareness Month, and so there'll be a whole bunch more videos coming out that will help share with you guys and help you guys decipher and help you guys understand if there's any other questions, those kind of things. Right? So
right. Thanks everybody for joining us.
Yeah, mahalo. Aloha, guys.
All right.